So I'm just going to go to the next page here. And this is stuff that I'm going to just be going over myself, but if you were following the instructions strictly on their own, then you'd go through it on your own. So, step one, now that we've successfully completed the unboxing. So I'm going to be opening up this green bag here, and I'm going to be looking for the bag that has the plastic dowel rim nuts in it. The other parts I'm not worried about for now. I'm also going to go into, let's see, the yellow bag. And what I'm looking for in here are the M5 nuts. Apologies. I'm looking for the M4 nuts. Let me just pull out the plastic Delrin nuts here. There we are. Now, these may not look like nuts, but they really are. And I'll show you why. Let me cut this open here. So I've just grabbed the short Z-axis lead screw, and you can see in the end here is a lead screw profile that's been cut into the plastic block, and you can see when I thread the lead screw into it, it mates perfectly with the nut. So that's why these are actually the backlash nuts. Now, to clarify, the reason why they're called backlash nuts, apologies, you don't need the M4 nuts. My mind is a little bit rusty right now. You're looking for the M5 nuts. I'm also going to grab, inside this same bag, the M5 bolts. And I'll show you why in just a sec. I'm going to put all this hardware back in for the time being, just so we don't get ourselves confused. Okay, so before I go telling you what's what, we're going to do the first step, which is seating the nylon nuts into the hexagonal bores in the back of the body here. I'm just going to grab this chair. Say hi to the camera. Pour some of these out here. Okay. So, believe it or not, these nuts fit inside this bore, but it's a bit of a tight fit. So, you can use a pair of pliers to squeeze those in, or maybe some vice grips, or a benchtop vise, whatever you're comfortable with. I'm going to use a mallet. You can also put a bolt in from the other side and twist the bolt down to pull the nut through. if you're going to be using a hammer, just make sure that the nut is sitting correctly so that you're not pushing it into the plastic incorrectly. And I'm just going to give this, oh, see, it's misaligned itself. I found a low profile drill vise. Now this is going to really help me out because instead of hanging the nut off the edge, it'll allow me to support it from all sides to hammer it more effectively, as now demonstrated. How easy was that? Goes to show that it's best to just keep about your senses. Oh wow, that one went in much faster, much more easily. As I say, it's best to just keep about your senses, and you know, even though you're putting together a bit more of a complicated machine that you might have never used before, the same rules of assembly apply as to any other circumstance. So once again, I'm just using the bolt to come in from the back, only screwing it on until I'm hitting the nylon part, no further. And that's just to make sure it stays vertical. And then I'm putting it in to the drill vise. The jaws are separated by a small amount to let the bolt head through, but to support the nut from both sides. I'm sure you can figure out a similar setup if need be. As you can see, that's how easy it can be. Let's not talk about it anymore though. Anywho, let's continue on. As you can see, there's a little bit of inconsistency in the Delaware nuts, just as far as the boring for the nut goes. This one, for example, I can just pull it through. Oh, you didn't even see that. As I was saying, I can just pull it through. No need for a hammer. So, it's possible that I just got one that was more on the tight side. So, I've got my 4 nuts, and they've got nuts in those nuts. I remember one of our machine owners called these backlash nuts robots. I think I'll call them robots from now on because they look like robots, and I just think that's a way more fun name. Looks like a robot head. So the other thing I was going to bring up is when you're threading the lead screw in place, let me thread it through from the other side. You can see it's got this flange, which is where the bottom lip of the robot is. Now, the reason this is an anti-backlash nut is because this flange has the lead screw profile cut into it, just like the body does. And so you can see that in the bag that the robots came with, you've got these 4 little set screws and 4 little nuts here. So let me open this up here. You take one of these set screws, you can actually thread it into the bottom of the plastic here. If you can see, I'm just threading it in. and it comes through the lip there. Let me grab a small Allen key just to make this process go a little bit faster. So, once it comes all the way through the lip there, it'll start pressing up against the roof of the robot's mouth. So, by doing this, it's kind of spreading this flange away from the body, and you can imagine that as the profile that's been cut into this plastic wears out over time, it would become looser. But since these both have profiles cut into them, if you spread them apart, if they've become worn out, then it essentially removes that slack. It compensates for the wear. And so that's why this is called an anti-backlash nut. Now, normally, when you're installing these set screws, you want to make sure that you're only tightening them up until they barely graze the roof of the mouth. And the reason for that is because they're fresh robots. They're fresh anti-backlash nuts. And so they don't need to be tensioned at all because there shouldn't be any give to them. However, over time, if you start to notice that the nut starts to get loose, all you have to do is just give it a bit of a turn, just a small turn, and then with whatever axis in hand that is loose, you then want to try to move it again. And if you feel there's some back and forth slop still, then you just give it a little bit more of a turn. And if that now removes the slop, then you're done. That's how tensioning the backlash nuts works, is you should just do a small amount of turning at a time and then feel again to see, is there any looseness? So anyway, that's how that process works. I'm going to unscrew this because I was tightening it in that demonstration, but I don't want them to be tight. The reason for the included nuts is because it's possible if you are having excessive vibration when you're cutting things with your machine that these set screws could come loose. And so if you take the included nut and you screw it on there and you tighten it against the plastic body, it will hold the set screw in place and make sure that it doesn't vibrate loose as easily. Another thing to note is that with these set screws, once your whole machine is assembled, it might be a little bit tricky to access the little tiny Allen heads on these set screws. And so if you'd like to give yourself a bit of an easier chance at adjusting them once the machine is assembled, you can take, if you remember I grabbed this bag of M5 bolts, you can take some of these because there's extras and also thread them into the robot mouths as a replacement for the set screws. So instead of using the set screws, you're using these bolts. So the set screws, you could set them off to the side. The only benefit that this has is that since the Allen head on the bolts are larger, it's easier to get your Allen wrench located into the head in order to tighten it when you're performing maintenance on your machine and taking up that slack. That's the only upside. A downside is that they're longer, so on some axes they stick out a bit and they remove some of the motion of the machine. Like it reduces the cutting area by a small quantity by the amount of stick out that the head has. So it's up to you which one you want to use. For me, I usually go for these larger bolts, just because I like being able to reach them more easily. But to be honest, I think for the average user, I would recommend that they use the set screws instead, because they're lower profile, and most of the time you're not going to be using the machine so often that you'll have to perform a tightening on the set screw very often. Anyways, I'm sure you're already watching this video at 1.5 times speed, because I am rambling. But I hope that you find my ramblings, or at least I hope some of you find my ramblings, a little bit informative. So, for the time being, I'm not going to bother putting the nuts on, and I'm going to be using the set screws. The fit of the set screw into the dollar nut is already pretty tight, so for the time being I don't have any fear that it's going to rattle loose. And that's how it should be on your nuts as well, your robots. The set screws should fit relatively tightly. So I'm going to leave these nuts off. And I'll set these aside. And I'll set these bolts aside. And I'll unscrew this, since it was just for demonstration. Okay. That was very long-winded. Ah, yes. This is a sub-assembly, these nut blocks. We're just going to do another sub-assembly here. Going to be going back to the green bag and grabbing these guys here. I'm just putting the bags and stuff off to the side to keep the table clean. So these guys here are Acme locking nuts. So these are nuts that, if I take the Acme lead screw, they thread on, and they have the Acme profile cut into them, and they also have a threaded hole here where you can take these little set screws, and once you twist them into place like this and you tighten them down with an Allen key, obviously, but I just did this one by hand, you can see that it's going to lock in place on the lead screw. Obviously this one has a little bit of movement to it because I just tightened it by hand, but yeah, the set screw locks the nut down to keep it in place. So all we're doing here is we're just going to take each one of these nuts and we're just going to do just like 1 or 2 turns just to get the set screw barely on the nut. And then we'll come back to using these later. So that's another sub-assembly. And you can see we have a little bit of extra hardware just in case anything goes missing. But I will put that off to the side. Okay. Ah, yes. So now we're going to, I'm going to clean this area back up a bit. Now we're going to be assembling the primary Z-axis assembly. So what that involves is the Z-axis plastic printed part, as I mentioned earlier. It's going to require the steel plate here. Remember earlier I also mentioned to set the Z-axis stepper motor to the side. So I've got that set off to the side here. If you recall, it's the one that says threaded on the back. We also need a couple more of these M5 nuts. And we need a couple more of these M5 bolts. And we're going to reach into the green bag again and grab our flange bearings here. We're going to be grabbing the short lead screw. We're going to be grabbing these Acme locking nuts. We just need one of them for this step. We're going to be needing, the pulleys and the belt, which is also in the green bag. So most of the stuff from this step is coming from the green bag, or it's coming from the yellow bag. So the first step that we're going to do is we're going to take two of these nuts out, and you're going to see this plastic part here is going to have hexagonal bores inside of it, and you should be able to push the nuts into the bore. For you, if it fits a little bit tightly, you can just use the same technique we used for the anti-backlash nuts, but for me, it was just a press fit in with my fingers. The next thing we're going to do is set up the motor. So when we have the motor here, and we've got the plate here, you can see that the motor can kind of fit on top of the plate like this. And the only thing we need to be concerned about is that the white connector that's at the back here of the motor is facing towards this bent arm. So the white connector is facing towards the bent arm. I'll place this down on the table, and we're going to take 4 of these long bolts, and these can just be threaded through the slots in the plate into the motor mount. I'm going to Just grab an Allen key so I can do this faster. Maybe I can multitask. I hope you can see what I'm doing here. Now, the only thing is that I'm just going to make sure these aren't tightened down all the way so that they're a little bit tight, so that the motor can still slide along the plate here. Like that. Okay. And then, what's going to happen is you're going to have this part and this part, and you can see they've got very similar profiles from the top, and that's how they fit over each other, like this. So that's how they fit into each other. And now, grabbing two more of these bolts here, you'll notice that there are two more holes in the plate, which lead through to where you had the nuts that you pressed into the plastic from earlier. So I'm just going to tighten those on by hand until you're going to hit the nylon part. Now, if I had my drill on me, I'd probably just use an Allen key bit driver on my drill, because that speeds the process up quite significantly. But, you know, not everyone has a bit driver set with metric Allen keys or metric Allen bits, metric Allen bits. You know, this is what happens to you when you spend a couple days in mostly isolation on your own with this whole coronavirus thing going on. Get a little cuckoo. Anyway, all I did is I just snugged these up. You don't have to really crank on them because the nuts go into plastic, so you'll just end up deforming the plastic. You're just going down tight enough so that it's nicely secured against, like the two parts are fully attached now, the steel plate and the 3D printed part. Okay. Next thing we're going to do is we're going to be opening up the flange bearings here and grabbing just two of them. Now, these flange bearings are rated for both rotational and thrust force. I should say axial and rotational loading. And so what we're going to do in order to make sure that the Z-axis is able to rotate and take the force of plunging the tool into material is we're going to push one in from the top and make sure it gets seated all the way in, and one in from the bottom. And the one on the bottom will probably be a bit loose, so I'm just going to put this assembly on its side so that it doesn't fall out right now. But you can imagine that by sandwiching the flange bearings, well, actually, I will show you some more of the assembly before I complete the explanation here. Yes, what I should have told you to do is put the flange bearings in first, because this top flange bearing aligns the top and bottom more closely, and then tighten down these bolts. But it'll, for the most part, it'll work in either order. Okay, so I'm going to take the short lead screw here, and I'm going to put the locking nut onto it, and I'm just going to thread this on a little ways, and then I'm going to push it up through the bottom bearing, through the top bearing, up the top like this. I hope you were able to see this. Let's see. I've got the bearing in the bottom, the bearing in the top, just like that. Okay. Yes. Now I'm going to take my pulleys out. So, there's going to be two pulleys here. One of them has a much larger bore than the other, so you'll know which one fits on the lead screw because only one of them will. And there's an included Allen key here because some people don't have Allen keys that are this small. And the first thing you'll want to do is just, with the set screws that are on the pulleys here, you'll want to back them off just a little bit because they're kind of sticking into the bore right now. So if you don't back them off, then they won't fit onto the lead screw or the shaft of the motor properly. So I'm just backing that off a little bit. I'd say just one turn. And then I'm going to be putting this pulley here onto the lead screw. Like this. And you just want to get the... I just put my finger over the top here so that I can get the lead screw and the pulley flush. You can see I have it upside down so that the set screws are on the top. And then I'm going to take my Allen key and I'm going to tighten down on the first set screw. And then I'm going to tighten down on the second set screw. And then I'm going to go in with the base end and just give it one last snug up. Hopefully you got that. That's on there. And then obviously when I go to move this down, the bearing will want to follow. But if I just hold it in place, I can screw the nut here up to the top like this. Okay. And now comes the part where we tighten down onto the locking nut. This is an M3 set screw, so you use a size 2.5 Allen key. So the idea here now is that I want to be holding on the nut on the bottom, holding on the pulley from the top, twisting them opposite directions to clamp the two flange bearings together. And then when I've got them twisted in that direction, I'll be trying to maintain that clamp while I turn the set screw closed onto the lead screw. And when you're done, you should be able to pull in and out on the lead screw here, and you shouldn't feel any wobbling or movement at all. Should be quite tight. And so I can explain to you what's going on here is by sandwiching the two flange bearings in opposite directions, and then clamping down on them with the pulley on one side and the locking nut on the other side, we're essentially creating a basis for the lead screw where it's rotationally supported, as well as it's able to withstand axial forces in this direction, because in the pushing direction it's being supported by this flange bearing, and in the pulling direction it's being supported by this flange bearing, and so that allows it to remain stable against plunging of the tool or lifting of the tool, because the tool and the router and the whole x-axis has to continuously be lifted against the force of gravity, and so the top flange bearing supports that. So that's now a solid assembly there. Okay, now I'm just going to put the other pulley and the belt in place. This other pulley is also going to be going on what would be considered to be upside down. And so what you want to do is you want to pull the motor as far close to the lead screw as you can. Wrap the belt around the other pulley. Wrap it around the one that's around the lead screw, and then bring it over the shaft of the motor, like so. So now that you've got this in place, I should point out that there is a flat on the shaft of the motor. You can actually see it here. And so you should ensure that when you're tightening this pulley down, since it's got two set screws, it's got one here and one here, make sure that one of those is aligned to the flat on the shaft. So I'm just going to rotate this, and okay, so see now the flat's there and there's a set screw there, so they're aligned there. And then the other thing is just to make sure that the pulley lies horizontal. So obviously if I attach this pulley too far down, then the pulley will be at the belt will be at an angle, but I want the belt to be horizontal. So I'll bring this to around here, which is also about flush with the top of the motor shaft, and then that's the position I want to tighten it down in. So, as I said, I'll align, oh, sorry, I need the other Allen key. I'll align the flat of the motor shaft to where one of the set screws is going to come in. This will allow for the torque to transfer from the motor through the belt with very little chance of with absolutely no chance of the pulley slipping, and I'll just snug that up. And then here, I'm also going to take the other set screw and tighten that down as well. And if I remember correctly, the last step is to tension the belt. I'm just going to move this bag out of the way because it's empty. And the belt tensioning process is very easy because you can see that as the motor slides along the slots, it can tension the belt. So all we want to do is pull the motor as far away as we can, and then while we're maintaining that tension, we're going to tighten down on the bolts that go through to the motor. And these once again, you don't have to really crank down on these. You just snug them down nicely. And now you can see that the belt is tensioned. And you can see that when I'm twisting the lead screw, it's transferring over to the motor. Okay. Now, we're going to move on to the other part of the Z-axis assembly. The next subassembly we'll be making and this subassembly are going to join up once the other one is completed. So we're just going to set this aside for now. And what I'm grabbing is the linear rail assembly here. Let's see. The other thing that we're going to be grabbing are two of the backlash nut assemblies, the robot faces. We're going to be grabbing... we're going to be breaking out the V-wheels, which were in the green bag. Those are the V-wheels there. We're going to still be using the M5 bolts. We're going to still be using the M5 nuts. And then we're going to be going back into the yellow bag here, where we're going to be grabbing, where is it at? The M5 washers. And then we're going to be going into the orange bag, to grab the eccentric nuts. Which are these guys right here. So, the step kind of points out that you want to be inspecting your rails, that it moves relatively well. As I said, this one's a little on the tight side, but it's still passable. I think if you have an assembly that's a little bit too tight, then you should let us know so that we can get that sorted out for you. So, the primary step that we're going to be making here is doing another, what I call sub-assembly. And this is the V-wheel sub-assembly. And what the V-wheel sub-assembly consists of is simply the M5 nuts, all of them, the M5 bolts, and the V-wheels, all of the V-wheels as well. So when we're putting the V-wheel sub-assembly together, you're going to start with a wheel, and you'll notice that some of the wheels look completely normal, and some of them look a bit off. And what that is there's a little spacing washer in there that can sometimes be off-center, and so if we want to stick the bolt in there, then we're going to have to fix that. And to fix that, you just grab the small Allen key, or any other small, long apparatus, but I'm using the small Allen key from the pulleys that we set up in the last step, and I'm just going to reach in there and push the ring so that it's back center, just like that. So once you do that, you can then take an M5 bolt and you can put it through the V-wheel, and then on the other side you're going to put a washer, like so. So bolt, wheel, washer, and they kind of just sit upright like that. And you're just going to do that 12 times. Bolt, wheel, washer. Gonna adjust the inner ring. Bolt, wheel, washer. And you just keep going. I'm not going to speed through this part of the video at all. I figure you can probably follow through at the pace that I'm going at. By that I mean, if I speed up the video, you'll have to pause it because you're probably doing this alongside me. So instead, I will just keep working at the same pace that you're probably working at. Okay. Have some water. As you can see, there's some leftover washers, which are nice if you accidentally lose any. So I will set these aside because I didn't lose any. Okay, on to the next step. Let's see where we're at. Ah yes, so we're going to be attaching these wheel assemblies to the gantry here. And I will point out to you, if you're looking at the gantry, you can see 1, 2, 3, 4. Those 4 holes form a rough rectangle. Those are where your wheels are going to go in. The reason that the 2 top holes have a larger bore than the 2 bottom holes is because on the 2 bottom holes, we're going to be bringing the wheels in from behind and attaching them with a regular nut, whereas the wheels that are coming in from the top, we're going to attach with the eccentric nut. I will show that process to you. So, here I've got the 2 bottom holes. I know this is the bottom because we've got the notch facing upwards, which denotes the top. So I'm going to bring this in through the back. Like that. Might be a bit of a snug fit because of the paint, but that pushes through there. And then I just grab the nut and I tighten it down. And I'm going to do the second one as well. Bring it up through the bottom. Just going to wiggle it a little bit against the paint. Tighten down on the nut. Now if you recall, this is where the LongMill wrench comes into play, because you can use this to hold on to your M5 nut from the one side while you tighten down with an Allen wrench from the other side. And you just snug that up a little bit. And we'll do it on the other side. Snug it up, and we're done. Wheels are going to be nice and solidly in place. They're still nice and free spinning on the back. Now we're going to attach the top wheels. So this is where we're going to pull out the eccentric nuts here. Now, the reason they're called eccentric nuts, as you might be able to have guessed, is because the bore of the nut is off axis from the threading of the nut, ever so slightly. And by having this off axis threading compared to the bore, it allows us to, and I'll show it to you, if I take the nut and I push it into the bore here, as you can see, when I rotate it, it can change where the threading is located. And if I've got the wheel and it's coming in from the other side, like so, I haven't tightened down on that all the way. You can see, if I hold the cross section of the wheels here, if I spin this nut, it ever so slightly can bring this V-wheel closer to this V-wheel or further apart. And the reason why that's important is because that will allow us to use these V-wheels to clamp down onto the aluminum. So if you imagine, well, you don't have to imagine, I will show you. We've got the aluminum coming through like this. If I can offset this wheel upwards, or inwards I should say, towards this wheel, it will allow the two wheels to clamp down onto the edge profile of this aluminum in order to keep a tight contact to the edge profile of the rail. As you can imagine, this is also useful because even though these are made out of Delrin, which is pretty wear resistant, they will eventually wear over time. And so as they do wear out, since they are softer than the rail is, their diameter will slightly decrease. And in that scenario, it will introduce a bit of looseness to the gantry. And so if you want to remove that looseness, all you have to do is then rotate the eccentric nut just a little bit more, and then tighten this bolt back down. And now the wheels are closer together and they're able to re-engage onto the edges of the aluminum rail. So, now you understand how the wheel system works on the machine. So what I'm going to do for the time being is I'm just going to loosen the bolt in the back and rotate the nut in the front so that the off-center threading is as close to the top, as close facing upwards as I can get it. Since I want the wheels to be spread as far apart as they can be for the time being, because it'll make the process of sliding the gantry onto the rail much easier. So I'll space the wheels as far as I can, and space the wheels as far as I can. I will rotate the nut so that the threading is as far upward as it can be. And then I will do that on the other side as well. So these two top wheels are I'm just doing them up hand tight because we're going to be actually using the eccentric nuts to clamp down on the rails later on in the assembly process. So for now, they're just hand tight. So I will set that down. Let's see now. We're also going to be bolting the robots onto the plate. So to do that, I'm going to be grabbing 2 more of the M5 bolts. And let me just get my bearings here. We want the robot to be having his bottom jaw facing out towards the right. Remember, this is the top. If you're looking at the front of the machine like this is the top, this is the right side. So we want the robot's jaw to be facing out towards the right here so that it's easy to access for adjustment. So if I push this gantry down here, you'll notice there's 2 holes. So I can take my M5 bolts, put them through the holes, and into the body or the eyes of the robot. And you should just be able to push them in and thread them into the nuts. Just like that. So, as you can see, I'm just putting these bolts on, and I've got my robot with his bottom jaw facing outwards towards the right side. Now the one thing I'm going to make sure of is that I don't tighten these down basically at all. I'm just going to tighten the bolts to the point where the robot head, the backlash nut, is still actually a little bit loose. And the reason for that is because later on in the assembly process, it'll just allow us to, once the nut is riding along the lead screw, we can make sure that they're aligned to each other. Because you can see that the nut can kind of shake back and forth a little bit here. So we don't want to tighten this all the way down in the wrong alignment, because then it'll cause more wear between the screw and the nut. So we'll just leave it loose for now. Okay, so that's done. Yes, and we're also going to put the other nut, the other robot head, on to the Z-axis. This one is much easier to see because if you face the nuts away, just like I did on this side, you should be able to fit the robot head in behind here, and it'll barely just hide behind that notch there, and the 2 holes will align. That's when we're going to take 2 more bolts and put them through like so. And like so. So I'm just going to sit back down, tighten these on. And once again, we're going to leave this just a little bit loose. And we'll come back to them later to get them fully tight. Once we know that we've aligned the nut to the lead screw properly. And you'll see what I'm talking about once we get there. Okay. So this is when we're going to connect the two major sub-assemblies together. I'm just going to take the M5 bolts and M5 nuts, as well as our wheel sub-assemblies, the eccentric nuts, and the other robot head backlash nuts, and all my tools. I'm just going to set them all aside so you can get a better view of what's going on here. And I'm going to grab that sub-assembly back over to here. And you only need 4 parts to complete this assembly, I believe. Let's see. Okay. You're going to be going to the yellow bag, because inside here is where you're going to find both the long M8 bolts, which are 25 millimeters, and the M8 nuts. All right. So you just need 2 of each of these. Got 2 bolts. We'll stick that back. 2 nuts. It seems the air system is turned on, so I'm going to try to speak a little bit louder so you can hear me. So essentially, in this plastic part here, you're going to notice in the back there's these 2 holes that come through the front and go to the back, and there's a space for a nut to actually sit in the back here and in the back here, which is where the M8 nuts are going to sit. So if I take these 2 assemblies here, you're going to notice as well that there's a slot in the side of the plastic part here, which is going to fit the top plate here. Now, the only thing that you're just going to have to align here is the lead screw here is going to have to go into the nut here. So just kind of place that. I'm going to do this on the table just because it's a little bit finicky to do in the air in front of the camera. So I'm just going to line that part there, and then I'm going to rotate this on like this. Starts to pull the gantry assembly up, And once I've got it at a reasonable height, that I'm sure it'll all stay in place, these two holes where the bolts will go through, you should see that they've now aligned to the steel plate. And so I'm just going to put this on the side here. I can now take the nut into the back, into that bore. I can hold it in place with my fingers while I bring the bolt in from the front and twist it in place. I'll change my hands over so that you can see this a little bit more clearly. And I'm going to grab a 6mm Allen wrench so that I can get some better leverage on this large bolt, because the head kind of disappears inside the counterbore, so you can't twist it by hand anymore. But it's going to thread its way into the nut, and now it's close to the end of its movement, and I'll just give it one final snug up here, and that'll be now in place. And I'll do the same process on the other side. I'll hold the nut in from the back. I could show you. I'm just holding the nut in the back there. Putting the bolt in from the front here. I'll just hand tighten it until it disappears beyond the counterbore. And then I will use the Allen wrench to tighten it the rest of the way. And you just snug that up, like that. And now, you've got a full assembly here. You can see you've got the movement in the Z-axis, and the motor's tied to it, just like that. It's quite a hefty assembly, if I do say so myself. Quite a sturdy one. All right. I hope you're feeling good right about now, because we've only got one quick step left, and then this sub-assembly will be completed, and we can move on to the next one. And this is the hardest one. So we're really coming out the gate, giving you the hardest stuff at the start, and then you'll find that it starts to really breeze your way through for the rest of it. Anyway, don't take my word for it. I'm sure you can make up your own mind about it. You'll notice that in this gantry assembly there are 4 holes in a row higher up and 4 holes in a row lower down. And basically this is just to give you the choice between, and let me grab the router mount so you can see here. Got the router mount. Of course, it's got saran wrap on it because it wants to spite me. And you can see that this is the front part that clamps into the body, and the body has 4 threaded mounting holes in the back that will align with the plate here. So the key takeaway between these two positions is that the lower set is ideal if you want to get your router closer to the table for cutting, like if you're going to be using primarily smaller cutting bits for engraving or whatnot, and your material is going to be quite thin, then it's nice to have your router closer to the table with the smaller bits in the collet to get that to cut through those tiny materials. But I'd imagine for most of you, you're going to be cutting larger, thicker material with larger bits, and in that case, you want to be using the middle set of holes, also because it gives you that little bit of extra rigidity. Since there's a small lever arm between the bottom set and where the guide rails are, or the guide blocks are mounted, whereas in this middle point here, it's basically aligned with the guide blocks. One piece of advice I would give is the included bolts are M5, but the Allen profile that they have on the top is actually an M4 sized Allen profile, which means that it's easy for them to strip. So what I would do is I would just take these and not use them, and instead, since there are some extra M5 bolts that we include, I would use these. They're the exact same length, but they have the appropriately sized M5 head on them. So you can screw these into place and not have to worry now about the bolt head profile stripping out, because it's an actual M5 size Allen profile, like so. You actually need to be grabbing the bag of short M5 bolts, the 12mm long ones, and once you have those, you can be taking them around the back here and sticking them in through the back of the plate. And then essentially, the easiest way to do it is just to put the assembly on its side, bring the bolts in from behind, and hold the router mount while you hand tighten all of the bolts in, just to start them threading. And then you can pull out your Allen key and start to tighten it down. And as you're tightening it down, you can hold onto the router mount like this and pull it downwards evenly, so that as you finish tightening, the router mount could be nice and flat or parallel against the bottom of the plate here. Since the holes that are cut by the laser in the steel plate are very accurate, but slightly oversized, so this way you're aligning all of the bolts to the bottom of the hole pattern. And that allows us to complete the Z-axis assembly. You'll have 2 extra bolts left over for the short bolts, and these I'm pretty sure you don't need, so you can put those off to the side. And I'm going to put the sub-assembly off to the side as well, because we're now going to be moving on to the Y-axis assembly.